Hi, Chem Peeps. Let's talk about ions. There are three types that I'm going to talk about today: anions, cations, and polyatomic ions. Let's start with cations. They tend to form the positive charges. They're on usually the metals, and they're found on the left side of the periodic table and then down below. They do follow a family trend, so that means like family 1 here is going to form a +1, family 2 is going to form a +2. Then let's jump over these transition metals here in the middle. We'll come and talk about those in a minute. Then family 13 forms a +3. Family 14, I tell my students, can be either plus or -4, and in fact on this chart they could even be a +2, but I tend with first year plus or -4. The lanthanides and actinides down below, they can be +3 and +3 and +4. Some oddballs are the transition metals. Yep, transition metals, they can have multiple charges. And so I usually give my students just a small chart of common ones that they might run across. The copper can be +1 or +2. You can see gold and iron and lead and mercury, nickel, silver, tin, and zinc. They can have multiple charges. These tend to be the more common ones that you're going to use, but in a later video we're going to talk about cross-up, so that if you don't have it on this list, you could determine its charge in a compound. Going on to the next one, the anions. Let's look at that. The anions tend to be your nonmetals, which are found on the right side of the periodic table over in here. Okay, and they become a negative charge because they are gaining electrons to get an octet, whereas the metals, which we talked about just prior to this slide, they form a positive charge because they're losing electrons to form an octet. Some oddballs that you might run across, not real frequently, but sometimes hydrogen, which is in atomic number block number 1, which tends to form a +1 just like the rest of that family or that column, sometimes is a -1. Well, how are you going to know if it's +1 or -1? In a compound, when hydrogen is forming its typical +1 charge, its name will be hydrogen. When hydrogen is in a compound and it's going to have a -1 charge, its name will be hydride. And that's usually how you're going to tell the difference. So let's talk about polyatomic ions. So poly means many, and atoms obviously group together, and they form a charge when they're together. So these groups of atoms come together and they covalently bond with an overall charge. That then allows them to move on and ionically bond to something with a positive charge, usually an atom or another polyatomic ion. You can see here I've included a chart that I would allow my students to use until they get into the upper levels. And so you just need to become familiar with them. There's a lot here if you're learning them, so by memory. Let's look at nitrite and nitrate. One thing that can help you, or a hint that might help you, is ite and ate as endings. That's pretty common. The ite polyatomic ion is going to have one less oxygen than the ate. So they're going to have the same nitrogen, the same overall charge, just a different number of oxygens differing by 1. So that can help you, and there's a few that are like that. There's sulfate and sulfite. There's nitrate and nitrite. And then if we go over here, there's a group of 4, and you can see the ones in the middle here are chlorite and chlorate. And indeed, they differ by 2, or 1, I'm sorry. The ClO2 minus 1 is the ite, and ClO3 minus 1 is the ate. But then there's another 2 in this set. If you look, there's one here called hypochlorite, and then there's one down at the bottom called perchlorate. And that's where our next hint comes from. Hypo is always going to be one less oxygen than the ite. And the per is always going to be one more oxygen than the ate. So if we look at this example here, we have them going from 1 oxygen to 2 oxygens to 3 oxygens to 4 oxygens. Notice the whole set has 1 chlorine and an overall charge of -1. The only thing that differs is the number of oxygens. And so hypo is 1 less, per is 1 more, ite is 1 less than 8. And so that's some hints to help you with that. Okay, want to determine oxidation numbers in compounds and polyatomic ions? Check my next video on that on Chem Chats on YouTube.